Welcome to Brain Vision.
In this question, is about Compton scattering, and then in this case, we are comparing two successive Compton scatterings and one Compton scattering. Okay, so so there are four parts in this question. In part A, we want to derive the formula for two successive Compton scatterings. The first one with angle theta 1, the second one with angle theta 2. Okay. So we'll be using the Compton scattering formula. Lambda prime minus lambda is equal to h over mc 1 minus cosine phi. Okay, so first scattering. Here we have lambda prime minus lambda is equal to h over mc 1 minus cosine theta 1. And then for second scattering, here we have lambda double prime minus lambda prime is equal to h over mc 1 minus cosine theta 2. Okay, to find the total shift in wavelength, total shifts in wavelength. Okay, so this is equal to lambda prime double prime minus lambda. So we just add up 1 and 2. We just add up the two equations. So we have h over mc 1 minus cosine theta 1 minus h plus h over mc 1 minus cosine theta 2. Okay, you simplify this, you get h over mc 2 minus cosine theta 1 minus cosine theta 2. Okay, so this is the expression for two successive Compton scattering. Okay, then in part B, we want to find we want to compare the shift between two successive scatterings of half angle with the shift in wavelength with one scattering of angle theta. Okay, so when you have two successive scatterings of theta over 2, the shift in wavelength delta lambda is equal to h over mc 2 minus 2 cosine theta over 2. Okay, and then you compare with one Compton scattering of theta. Okay, the delta lambda. Okay, just label the delta lambda differently. You have h over mc 1 minus cosine theta. Okay, in general they are not the same. In general, delta lambda 1 is not going to be equal to delta lambda 2. Okay, because 2 minus 2 cosine theta over 2 is not in general not equal to 1 minus cosine theta. Okay, we will consider the case when they are the same. Okay, if delta lambda 1 is equal to delta lambda 2, then we have 1 minus cosine theta is equal to 2 minus 2 cosine theta over 2. Okay, so we can use the double angle formula for the cosine theta. 2 cosine squared theta over 2 plus 1 is equal to 2 minus 2 cosine theta over 2. So the 2 cancel out. Okay, so you have 2 cosine squared theta over 2 minus 2 cosine theta over 2 equal to 0. Okay, so we have cosine theta over 2 times cosine theta over 2 minus 1 equals to 0. So we either have cosine theta over 2 equals to 0 or cosine theta over 2 equals to 1. Okay, so this means theta is equal to 180 degrees, or theta equals to 0 degrees. So other than 0 degrees, the other angle for delta lambda 1 equals to delta lambda 2 is when theta equals to 180 degrees. Okay, so generally they are not the same. Okay, so in part C, suppose we have two successive Compton scattering of 30 degrees. Okay, what would be the shift in wavelength? Okay, so lambda double prime minus lambda is equal to h over mc. 2 minus 2 cosine 30 degrees. Calculate this, you get 0.268 h over mc. Okay, so this is the answer for part C. Okay, then in part D, we'll look at the shift in wavelength for one Compton scattering of 60 degrees. Okay, 1 minus cosine 60 degrees, and you get 0.5 h over mc. Okay, if you compare the answer in D with the answer in C, we see that the shift in single Compton scattering of theta is greater than the shift in two successive Compton scattering of I should make it more specific. Here we have 60 degrees is greater than the shift in two successive Compton scattering of 30 degrees. Okay. Okay, so the answer greater than. Okay, so that which is consistent with what we have in part B, as we said that they are not the same in general. Okay, and that's all for this question.